Hello viewers, you are welcome to this video lecture. I am here to present the 12th video lecture from a chapter 3. Chapter 3 deals about the geometric design of the highway. In the previous videos will be deals about the introduction about the geometric design of the highway, for example the horizontal alignment, vertical alignment, the cross section, and also the stopping side distance and passing side distance also as introduction will be discuss, and also discuss about the different type of the design control and criterias. For example, is the functional classification, the terrain, design vehicles, density, traffic volume and composition, and also will be deals about the design speeds, and also will be deals about the highway cross-sectional elements. There is different type of elements will be discussed. The first is the lane widths, shoulders, drainages, the back slopes, and also the medians to divide the highways, and lastly will be deals about the right of way, and also deals about the elements of geometric design. In the previous video also deals about the horizontal alignment. As the horizontal alignment is for example it is designed for the there is different directions, so there is different directions, there is provide the horizontal curves, and also deals about the horizontal curves is designed based on the appropriate relationships between the superelevation, fraction, and the design speed is very important. For those relationships will be there is R minimum is equal to v square over 127. E plus f also will be discussed based on ERA manual, and also discuss about the different types of the horizontal curves. There is a circular curves, it is a simple circular curves, and also will be a compound curves. So compound curves have similar two curves will be combined, similar direction, but there is different radius. And also the other type of horizontal curves is a reverse curve. A reverse curve is two curves will be joined together with opposite direction, also will be deals, and also deals about the design elements of horizontal alignment. For example, it is a tangent, a straight line, and also will be the curves, and also the transition curves, and also super elevation and fraction will be discussed in the previous videos. Now will be deals about the horizontal alignment curve examples. For example one will be the deflection angle is 4 degree, curves is 55 degree and 25 minutes, and point of intersection is also given. It is 245 plus 97.04. The required is to find the length of the curves, the tangents, and the stations of point of tangents is the required parts. So the given parts will be deflection d is equal to 4 degrees, and also the total deflections will be 55 degree, 25 minutes will be is equal to 55 degree point 417 degrees. So we have required will be the relationships between the deflection angle and the radius is equal to, it is a given empirical volume, empirical formulas. So R is equal to 5729.58 divided by 4. We have get the minimum radius is 1432.4 feet. And we have the first required is the length. The length will be 2 pi r delta over 318. So there is 2 times pi will be 3.14, and the radius will be calculated 1432.4 times the delta. The deflection angle will be 55.417 degrees divided by 316. The length between the point of curvature and point of tangent is 1385.42 feet. And also we can calculate the point of curvatures. So the point of intersection is already given, 245.97.04, and the point of curvature is equal to point of intersection minus the tangent. So the tangent is already calculated. So 245 plus 97.04 minus 752.29. So the point of curvature will be 238 plus 44.75. We already calculate the point of curvature. We can calculate the point of tangent. The point of tangent will be the point of curvature plus the curve length. So point of tangent is equal to point of curvature plus the length. So 238 plus 54.75 plus the length is already will be calculated by using 2 pi r delta over 316. So we have get 1385.42. So the point of tangent will be 252 plus 13.17. And also will be calculate for example 2. Example 2 is the intersection angles of 4 degree curves is 55 degree 25 minutes, and the point of curvature is located as station 238 plus 44 plus 0.75. So determine the length of curve. The station is at point of tangents and also deflection angles, the whole lengths also for setting out the curves at whole station. The whole station means there is the last party will be 0 0. So the next whole station will be 239 plus 0 0. Next 214 plus 0 0. So we can calculate the radius of curves as in the previous examples. Also will be calculate 5729.58 divided by the deflection. So the minimum radius will be 1432.4 feet, and the length of the curves already will be calculated. So r times delta pi 3.14 of divided by 118. So the radius already calculated, the deflection will be there, and times by pi divided by 118. So the length of the curve is 1385.42 feet. So the first point of intersections will be the point of intersection we will be get by point of curvature plus the length. Point of curvature will be already given. Curvature will be given. Point of curvature will already given plus the length of the curve. So we can get point of tangent. So the point of tangent is 252 plus 13.17 station. the distance between the point of curvatures and the first station. So divide the force setting out up to the point of tangent. So the first whole station will be 239 plus 00 minus point of curvature. Point of curvature will be 239 plus 54.75. So we have get the first distance will be 55.25 feet. So we have get deflection, the first deflection is over the total deflection delta is equal to L1 over L, the total length. So the first deflection is the required part. The delta will be this one, so 55.4167 degree. So this one is converted into degree, and the first length will be the PC in the whole station is 55.25 divided by the whole length from point of curvature up to the point of tangent, 1385.52. so the first delta is equal to 2.21. So the first delta also will have calculated. The first chord length will be 2 times the length. The length will be 1432.44 times sine delta. The first delta over divided by 2. It is the first chord length will be 55.25 feet. So the first deflection angle at the station 239 plus 00 is deflection over 2 1 this one is 2.2110 divided by 2, 1.105. Similarly, we have also calculate for the last deflection. The last stations will be point of tangent will be already calculated. So 252 plus 13.17, and the whole station is 252 plus 00. So the first length will be 13.17 feet. So the first deflection, the deflection over 2, so times by the length over 2. So deflection will be this one, 13.17 divided by 1385.42 times by 55. It already calculated. Deflection, it is given, over divided by 2 is 0.6034. So the first the last coordinate will be 2 times the radius times by the the deflection. So the deflection will be 13.17. So we have the last chord length will be 13.17, and the deflection in the whole stations will be 4 degrees. So we have 2 times the radius times 4 over 2. The whole stations from 239 from 239 plus 00 up to 252 plus 00. The whole stations will be 99.78. So we can the calculation parts will be in the table forms. So the point of curvature is 239 plus 44 plus 75. It is the deflection 0 and the chord length. The second whole station will be 239. So the deflection angle is 1 degree, 6 minutes, 18 seconds. It is already calculated. The chord length will be 55.25. So the chord length will be 55.25. The second, the whole stations will be 214. So we have added the deflection angle. So the deflection angle will be 99.9 98 we previously calculated, so the previous 99.98. This one we from this 239 up to the last whole station to 252. So up to 252 we use 99.98. And also the last deflection points also will be 13.17. It is already will be calculated. So the third examples will be the design of simple horizontal curves also will be calculated. This will be incorporate the external distance, the tangential distances, the point of curvatures, the point of tangents, all will be incorporated. So the curves have a deflection angle of 23 degrees, 80 minutes 02 seconds, and the radius will be 1432.6 meter, and the point of intersections will be 5 plus 053.87 station is the point of intersections, and the calculates or the required part is the tangential distance, external distance, curve lengths, point of curvatures, and the point of tangents also will be calculated. And come to the solution part. The tangent will be radius times tan delta over 2. The radius will be already given, 1432.6 times tan delta will be 23 degrees, 80 minutes, and 2 seconds divided by 2. So we have get 295.35 meters. This example will be a metric system, so we have in 3 digits. External distance also will be radius sec delta over 2 minus 1. In the previous video will be how to calculate the formulas will be C. So radius is 1432.6 times 1 sec means 1 over cos delta over 2 minus 1. So we have get 13.12 meters. And the length will be delta times radius times 2 times pi over 316. So the delta is 23.3. So this one is converted into the degree parts. We can calculate as 23 degree plus 18 over 16 plus 2 over 316. We have added these parts, will be get the converted into degree. So times the radius is 1432.6 times by 2. The pi value is 3.14 over divided by 316. We have get the length between the point of curvature and point of tangent will be 582.51 meters. So point of curvature will be the point of intersection minus the tangent. The tangent, the point of intersection already given. So 5 plus 053.87 minus the tangent will be calculated previously to 295.35. So we have get the point of curvature will be 4 plus 758.52. So the last part is point of tangent. Point of tangent will be point of curvature plus the length. So point of curvature will be get 4 plus 758.49 plus the length will be 582.51. So we have get the last point of tangent will be 5 plus 341.00. Thank you for listening my presentation.